Hello students, hope that all of you are doing well. Today I am continuing with class 10 mathematics and our next chapter is real numbers. It's actually chapter 1 of class 10 mathematics. The first theorem of this chapter is called Euclid's division lemma. This name is new for you, but the concept is not new. You might have studied this concept in your very early class, maybe class 4th, but in another way or in another name. It has given a particular name and the name is Euclid's division lemma. Now listen carefully. What is Euclid's division lemma? Euclid's division lemma states that if we have two positive integers a and b, small letter a and small letter b. If a and b are two positive integers and if a greater than b, then there exist two unique integers q and r. There exist two unique integers q and r such that a is equal to bq plus r, where r is greater than or equal to 0 but less than b. By hearing this statement, you may feel something great, but when I explain this statement, you will come to know that it is a fact that is already known to you. I repeat the statement. For any two positive integers a and b, where a greater than b, there exist, means always there are, two more unique integers q and r, such that a is equal to bq plus r. I hope all of you are familiar with this thing. A is equal to bq plus r. What is it? This is called division algorithm. When a is divided by b, the quotient is q and the remainder is r. This is the meaning of this Euclid's division lemma theorem. When a number a is divided by another number b, always you will get a quotient q and a remainder r. And this quotient and remainder are unique. Unique means if I do the division or you do the division, the value of q and value of r will be same. That way it is called unique. For example, let us take an example. Let a is equal to 10 and b is equal to 3. When a is divided by b, what is the quotient? Quotient is 3. And the remainder is 1. That's all. If I do the division or you do the division or anybody do this division, for these two fixed numbers a and b, this q and r are always same. That's all. So if a is divided by b, then always there exists a q and an r. This q and r are unique, means the answer will be same all over the world. That's all. So simply, and this a, b, q and r will now satisfy this condition. A is equal to bq plus r, means dividend is equal to divisor into quotient plus remainder. 10 is equal to 3 into 3 plus 1. Did you understand? This is what you have learned maybe in class 4. Now the same thing is given in the form of a theorem, and the name of the theorem is Euclid's division lemma. So now in simple words I may repeat it again. If a number is divided by another number, you will always get a unique answer, that is quotient and a remainder, in such a way that dividend is equal to divisor into quotient plus remainder. That's all. And one more thing. Here you can see where R means remainder, is greater than or equal to 0. We know that whenever an integer is divided by another integer, the remainder will be either 0 or more than 0. But it will be always less than b. What is b? Divisor. So this is a rule that you might have studied again in smaller class. Whenever we divide an integer by another integer, the remainder will be greater than or equal to 0 or less than the divisor. So the only thing is that a special name is given, but the thing is the same that you have learned in smaller class. Dividend is equal to divisor into quotient plus remainder. So if you are any two numbers, and take the larger number and divide it by the smaller number. When you divide the larger number by the smaller number, you will get a definite answer as quotient and you will get a definite remainder, Q and R. And there is a relation between all the four, and the relation is dividend is equal to divisor into quotient plus remainder. That is, A is equal to BQ plus R, and the remainder will be always greater than or equal to 0 but less than B. B means divisor. Remainder is greater than or equal to 0 but less than the divisor. It is all about Euclid's division lemma. Now we are going to study the practical applications of Euclid's division lemma. Euclid's division lemma can be used to find the HCF of two or more numbers. I am telling you, this is already done by you in smaller class, but not under this name, but the method is known to you. Whenever you have to find the HCF of two numbers or more than two numbers, there are two methods, and one method is known as long division method. Long division method. That long division method is same as Euclid's division algorithm, or you use Euclid division lemma. I will explain with an example how to use Euclid's division lemma to find the HCF of two or more numbers. So, along with that, I am doing exercise 1.1. Exercise 1.1, question number 1. And question number 1 of exercise 1.1 is, use Euclid's division algorithm. Euclid division algorithm is nothing but the statement of Euclid's division lemma. Step by step procedure is called algorithm. To find the HCF of first one, 135 and 225. Use Euclid's division algorithm to find the HCF of 135 and 225. So these are the two numbers A and B. We will always take the greater number as A and the smaller number as B. Using Euclid division algorithm, when we divide the greater number A by the smaller number B, let's see what is the quotient. 225 divided by 135, 1 times 135, 90. So we know that remainder is not 0. So we will write the first step. 225 is equal to 135 into 1 plus 90. A is equal to BQ plus R. This division will continue until we get the remainder 0. When we get the remainder 0, the corresponding divisor is the HCF. This is what is called long division method. Now we will continue the division until we get the remainder 0. When we get the remainder 0, the corresponding divisor is the HCF. Now again we will take two new numbers as A and B. Now which are the two new numbers? Now A and B are 135 and 90. Now 135 is greater than 90, so 135 will be treated as A and 90 will be treated as B. So now 135 will be divided by 90. Answer, quotient is again 1 and the remainder is 45. So the next step, 135. Among these two, we will take the bigger number as the new A and it will be divided by the previous remainder, that is 90. So we have divided B is equal to 90, Q is equal to 1 and the remainder is 45. Once again the remainder is not 0, so we will continue the division. Now which are the two A and B? Now 90 is A and 45 is B. 90 and 45, bigger number is 90, so 90 will be taken as A, 45 will be taken as B. Again we will continue the division. Now 90 is the divisor, 90 is the dividend, 45 is the divisor. Do the division. Now the remainder is 0. So we will write third step, 90 is equal to 45 into 2 plus 0. Now when the remainder is 0, the corresponding divisor. When the remainder is 0, the corresponding divisor is the HCF. So what is the HCF of this question? 45 is the HCF. I repeat, when we do the long division, surely you will get 0 remainder at some extent. Continue the division until you get the remainder 0. When you get the remainder 0, the corresponding divisor is the HCF. So the answer, therefore, HCF equal to 45. I hope all of you understood. This is the application of Euclid's division lemma. For any two numbers A and B, we can find its HCF by Euclid's division lemma. Among the given two numbers, take the bigger number as A and smaller number as B and divide A by B. You will get a quotient and a remainder. If the remainder is not 0, take the remainder as B and the previous divisor as A and continue the division. You will get a new remainder. Continue the division until you get the remainder 0. When you get the remainder 0, the corresponding divisor will be the HCF. Now there are two more questions. Do these two questions as homework, and if you have any doubt, you can ask your doubt in the comment box. So I am leaving the two questions of question number 1 as homework. Now question number 2. Show that any positive odd integer is in the form of 6 cube plus 1 or 6 cube plus 3 or 6 cube plus 5, where q is some integer. I repeat the question. Show that any positive odd integer can be written in the form of 6 cube plus 1 or 6 cube plus 3 or 6 cube plus 5. See the answer, 6 cube plus 1, 6 cube plus 3, 6 cube plus 5 indicate it is like b cube plus r. Everywhere b is same. What is that b? 6. 6 cube plus 1, 6 cube plus 3, 6 cube plus 5. It is like b cube plus r. Only r is changing 1, 3, 5. But b is same. So for solving this question, we will let the positive odd integer. We have to prove every positive odd integer can be expressed in the form of 6 cube plus 1 or 6 cube plus 3 or 6 cube plus 5. So that positive odd integer is taken as A. And let the divisor here is 6. Why did we take it as 6? Because we have seen in the answer, we have to bring it in the form of 6 cube plus 1, 6 cube plus something something. So by seeing that 6, we are taking its divisor as 6. Now, using Euclid's division lemma, now we can write A is equal to B cube plus R, but B is 6, so 6 cube plus R, where R is greater than or equal to 0 but less than 6. Here the divisor is 6, so what are the possible remainders? 0, 1, 2, 3, 4, 5. So what are the possible ways of writing A? Now if I am expanding this by giving the values of remainder from 0 to 5, less than 6 but greater than or equal to 0. That is, I can open it in the form of A is equal to 6 cube plus 0. The first remainder is 0, or A is equal to 6 cube, or A is equal to 6 cube plus 1, or A is equal to 6 cube plus 2, or A is equal to 6 cube plus 3, or A is equal to 6 cube plus 4, or A is equal to 6 cube plus 5. These are the possible ways in which we can write A this time. When any positive odd integer is divided by 6, these are the possible ways. Remainder can be 0 to 5. So 6 cube plus 1, 2, 3, 4, 5. Now listen, a very important point. Whenever an odd number is divided by an even number, here the divisor is 6, which is even. Did you ever check, when an odd number is divided by an even number, what are the possible remainders? Did you check again? I'll give you an example. Take a positive odd integer, say 9, and take a divisor in even. I am taking the same 6. 9 divided by 6, remainder 3. Got it? Take another odd integer, 7. 7 divided by 6, remainder 1. Take another odd integer, 11. 11 divided by 6, remainder 5. Take another odd integer, 13. 13 divided by 6, remainder 1. 15 divided by 6, remainder 3. 17 divided by 6, remainder 5. What I mean to say is, everywhere you can see the remainders are 1, 3 and 5 when you divide it by 6. When an odd integer is divided by 6, which is an even integer, the possible remainders are 1, 3 and 5. 1, 3 and 5. What does it mean? When a positive odd integer is divided by an even integer, the remainder will be always odd. Yes. When a positive odd integer is divided by an even integer, the remainder will be always odd. And which are the odd numbers here? 1, 3 and 5. So what are the possibilities? A is equal to 6 cube plus 1, or A is equal to 6 cube plus 3, or A is equal to 6 cube plus 5. So you have to write one statement here. Since A is an odd integer and B is even, the remainder will be always odd. Therefore, the possibilities are A is equal to 6 cube plus 1, or A is equal to 6 cube plus 3, or A is equal to 6 cube plus 5 are the only three possibilities. 0, 2, 4 are not possible because A is odd and B is 6, which is even. The remainder will be always odd. Here the remainders are odd remainders are 1, 3 and 5. So the answer is 6 cube plus 1 or 6 cube plus 3 or 6 cube plus 5. I hope all of you understood. Now let's see question number 3. An army contingent of 616 members. Army contingent means a group of army having 616 members is to march behind an army band of 32 members. So an army band of 32 members, behind this army band of 32, 616 army men. How to march? How? In a parade. The two groups are to march in the same number of columns. The two groups how to march in the same number of columns. What is the maximum number of columns in which they can march? Maximum number of columns in which they can march means there will be band in the at the front, and after some, and behind this band people who have to march, this 616 army people have to march. But we know that in army, in each line the number must be same. What is the maximum number of rows or maximum number of lines in which they can march together? See, there are so many options if that maximum word was not there in the question. They can march in a single line. 32 band people will stand in a single line. Behind that, 616 army people can join. They can march in two lines. There are 32. So 16 and 16. They will make two lines. 16, 16. Behind them, 616 divided by 2. 308 and 308 will stand behind them. So in minimum number, or if that number was not a matter, they have various options. But what is the question here? What is the maximum number of lines that they can make in which number of band people and number of army people will remain the same? In this way, what is the maximum number of lines that you can form? Mostly in the questions of this type, when you see or hear that word maximum, remember highest. So what is the answer? Highest common factor of 32 and 616. The answer of this question is simply HCF of 32 and 616. You can find HCF of 32 and 616 as I did in question number 1. This is A and this is B. 616 divided by 32. Continue the division until you get the remainder 0. The divisor of the last step will be the answer. But how to identify this type of question? HCF type question. You will be given two groups of different numbers. And you will be asked, by mixing them together, what is the maximum number possible while taking both the numbers together. This is called HCF, highest common factor. two groups of different numbers or many groups of different numbers, combining them together, we have to make a common group in which there will be maximum number of each group. This is the concept of HCF. So two different groups, they have to march together in such a way that there will be maximum number of lines and equal number in each group. This is the concept of HCF. So now you can solve it. Simply you find HCF of 32 and 616 and that is the answer. Maximum number of lines in which they can march. So that's all for today. I hope you understood the concept of Euclid's division lemma and its application. Main application is to find the HCF, and there will be word problems related to HCF. Try to identify the HCF type word problems. And we have seen a question number 2, odd integer expressing in the form of 6q plus 1, 6q plus 3, 6q plus 5. There are two more questions that is also like question number 2 expressing. That we will do in the next class. Till then, practice, go through the video once again, understand the concept. If you have any doubt, you can ask in the comment box. Till then, take a good care of yourself. See you. Bye bye.